Guys, you will need paper to write on to do this bell ringer. Let's get started. Let's get started. I said you'll need paper to do this bell ringer. I guarantee you guys, or at least I personally would not be able to do this bell ringer without some paper out. Personally.
Good morning.
Attention, salute, pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. You may now be seated. Sign-ups for Patriot Games will be posted on green flyers around the school. Sign-ups end on Tuesday, August 30th at 2 p.m. See Mrs. Hughes in the office if you have any questions.
Let me say this. I don't know that I put it in the question. My assumption was that you were dealing with a standard normal distribution. So, think about the fact that you are dealing with a standard normal distribution and what that tells you. Yeah, but you're dealing with a standard normal distribution with those standard deviations. Yep.
Any junior or senior interested in the Interact Club?
Standard thing is something that is...
Math is
very picky.
Are due by September 1st.
So it doesn't have broad.
Students in grades 9 through 11 are standardized.
It is standardized. We need a common way to talk.
That's high
Pick up the registration form in the front office. The answer to the cycle crash on the school. The cost of the test is $20.
Statistics, math, with personality.
That's it.
If you want to know more about the world around you, come learn through experiments and field trips in the science club. Our first meeting will be September 1st, September 7th. Flyers are posted around the school to join their reminder. Have a feeling Thursday and me with that.
Alright guys, let's say 3 to 4 minutes. Let's get that bell ringer done.
Classroom. Also, those of you that have first block class, please send students their party 3, 4, 5 additional time. Also, students, there are normal appointments.
Hey guys, Mr. Hinton's talking.
And hats and things worn in the building, sunglasses and things of those sorts. So if you have them on and you were seen, expect to get a detention or eyesight or something to that effect. Teachers, if you're allowing students to wear hoods and hats and things in the classroom, please stop doing that and remind them what appropriate dress code and behaviors all offer inside the building. Thank you. Have a great day.
Yeah, there's a couple of reasons.
Yeah, I know the reasons.
No, that's not why.
Can you hide your identity? Can you hide stuff in it? Definitely. I'd rather have something like that.
The high identity, also after the tornado, people use hats and things like that to identify the different gangs. So just to get rid of that issue. Huh? See where there was this one?
Yeah.
By the way, guys, I will point this out. You cannot use the standard normal distribution from the getting started. What's the rule that we need to use?
65, 95,
So close.
Empirical rule.
The empirical rule, which is 68, 95, 99.7. I would also say this. I will never do a problem like this without drawing it out. I would never do a problem like this without drawing it out. Much like Jackson Wood is at activity 2.2. Activity 2.2, you had the curve drawn and you had to shade the different regions. I would always draw it out. It's hard to do without drawing it. Huh? With your group for now, yeah? Nah, I'm never going to go over this bell ringer. Selita, I've gone over the bell ringer every day, haven't I?
I don't know.
attention when I do stuff in
That's
class.
why I need you to work it out.
That's why I need you to pay attention when I do stuff.
Where's my sugar?
You're not even trying right now.
I'm trying to see if I know it.
Where's your order for it? I mean, I see the 68 and 95, 99.7, but how did you get there? Did you talk with your group whatsoever?
Yes, and that's what they got.
So you just put down their
And that's
answer?
why I asked you to work it out, because every time I try to ask you to do it,
I'm trying to see if I know it.
I'm just looking at the eyes around here.
Somebody,
That doesn't feel, that doesn't
I
feel.
told you, no, you told me hold on like 10 times.
Well, you
So I
gotta
said,
finish what I was doing.
because you kept trying to get the answer, I needed to get the
Split back out.
Yeah, you can sit there and go back there. Oh, can I?
No, we're not.
Yeah, listen to.
I don't know.
If you didn't yesterday, read the whole thing, Hudson. Zaria. Peyton. Tori. Good. Brantley. Get an answer in. I'm collecting within 60 seconds. Gabby.
Some of the graphics, this is pretty cool. Isn't this 13? Between 1 and 2?
Yeah, that's not 2.5.
I mean,
That's 2.35.
84 minus 2.35.
Get an answer in. I'm about to collect. 10 seconds. Get an answer in.
help me understand. 3, 2, 1. It's okay. If you already had an answer in, it would collect it.
There you go.
So it's up here. Okay, so the most common response is 83.85. So let's look at it and break it down. And again, I need you to remember there's more than one way to approach this problem. So we're going to look at a couple. Now, once again, I'm always going to draw this out first. I'm never going to try to do one of these problems without drawing it out. And that's going to hold true for the next 2 lessons. All right, what's the first thing I need to mark, though, on my standard normal distribution? The mean, which is where? In the middle, not the middle, because that's not a thing. Okay, so what is the middle value for the standard normal distribution? 0. And then how do I identify where one standard deviation is?
Where the slope starts to go.
Some
The
point,
slope.
I mean, it's going down. It's not the slope.
When it starts to curve.
right, some point is right there.
It's some point. The
Yeah.
point of inflection. Remember, it's concave down like a frown, and then the point where it changes to be concave up like a cup, that's where your one standard deviation is, right? So it's not exact, but I would say about there. And remember, I can use that now distance to mark the next couple, right? So, and that's my 2 and 3 standard deviations. And then I would do the same thing here to do -1 and -2 and -3, okay? So I'm going to mark those. That's what I'm always going to do to approximate. It doesn't take very long as you identify that point of inflection. Now, where am I supposed to shade from and to? The -1 to 3? Was it 3? Oh, it was 3. For some reason I thought I did 2. So -1 all the way to 3. And we know that we're using 68, 95, 99.7. That's that empirical rule. So what's an approach to get to that 83.85? What'd y'all do? Lots of people got this answer of 83.85. Hudson.
You can add 68, because you know that's both the ones at 68.
So you know that both of these are,
68.
there's 68%.
And then the 1 and the 2 is 13.5, so I just added that. And then plus the 2.35, which is 1.2.
So 13.5 and then 2.35.
Yeah.
And so we just added those together. That is a possible way to do it. But, and so hold on a second, I'm going to come to you next. I just want to point out, that would require you to memorize and remember that 13.5 and 2.35. Totally doable. I'm not going to memorize all those extra pieces. That's just me. I'm going to use that 68, the 95, and the 99.7. The less I have to memorize, and the more I can just make it a little puzzle, the better it is for me. If you can memorize all that, go for it. That's your choice, right? Peyton, what you got?
I just took the right side of it, and
Okay.
I just kind of did as 50%, and then I took off the 0.15% because I knew that on the right side, all the way is 15, but if you only go to the...
So then that makes this 49.85.
I knew if you only go to third, it's 99.7, and 99.75 by 2 is 49.85.
All right, so I want to reemphasize that, right? We should know that that's that 99.7. So what's outside the 99.7? 0.3, but it's split between these two tails. So this tail that we're not using is 0.15. And you're saying that from here over is 50%, taking that away, 49.85, right? So we're using and playing around with things that we know. But what did you do from here?
I knew that negative one standard deviation away from the mean would just be 34%, because if you do it on both sides, it is 68%.
Right, so we have 68, half is 34. We add those together. Does that also get us that 83.85? That's closer to how I was thinking about it. That might actually be easier than the way I was thinking about it. I like it. Anybody else with a slightly different strategy?
So we basically just add.
I mean, you want the total area, right?
Right.
And a total is what operation?
Addition.
That's it. You got to know the 68, 95, 99.7 to get there. Okay, so here's how I did it, or how I was thinking about it. What do we know to be -3 to 3? 99.7. But I only have this half, 0 to 3. So how do I figure out what that half is? Divide that by 2, and I got 49.85. And then again, I knew this was 34. So I got exactly that same approach. Just, I didn't do the 0.15 and 50% minus it. I just know, okay, -3 to 3 is 99.7. I half it just to get that side, and then add my 34% to it. You don't have to know all those strategies. I just want you to see that there's more than one, but it all goes back to knowing what rule. The empirical rule of, what is it, Madison? Madison, you better finish that tea. Get up 10 minutes earlier and finish your tea before my class. The next time that happens, it's going in the trash. Is that clear?
$8 in the darn.
So, what's the empirical rule though?
Me.
No math.
Oh, 68, 95, 99.7.
There we go. The empirical rule, right? The percent of data within one standard deviation, 68%. The percent of data within 2 standard deviations is 95%. The percent of data within 3 standard deviations is 99.7%. I bring that up and I add that extra detail because I don't want you to forget it's not just 68, 95, 99.7. That's within 1, within 2, and within 3 standard deviations. Right? So it's all those areas. What are your questions before we continue today? And once, going twice. Feel good? Cool. All right, moving on from there. Okay. Slideshow, play. I have a little, there it is. Okay, so we did the bell ringer. So we're gonna have a quick discussion about that talk the talk that I gave back, because I didn't grade it, but I used it to get some feedback on where we were. The most common mistake is we are not recognizing what I am asking for with shape. Pay attention as we go over the idea of shape. We're going to finish up empirical rule. We're going to get into lesson 3, z-scores and percentiles. For those of y'all who asked, we are about a week away from our test with this unit. My guess is at the very latest we will finish new content on Tuesday. There's a chance of us finishing it on Monday. But expect an understanding check on this stuff on Monday, and a test either Wednesday or Thursday next week. Okay? So I tried planning it out. I always have to play around with it, but be aware that that is coming. All right, talk the talk. So again, describe the shape of each curve. I saw a lot of people talking here about the height or the width of that curve. What are the things I'm actually looking for with this talk the talk? JC, I just gave it back to you, I thought. Were you here when we did it? You had it there. That's all I need. Oh, is there a possibility? I don't know where yours is. I put them all together. I am super confused now, and I'm so sorry. I don't know how that could have possibly not been in my thing. That's the only place I put it. Did I put JC's down on anybody else's desk? Could you have accidentally just put it without thinking in your notebook? The answer is no. Then I have no idea. Then I'm wicked confused. Yes, Tori.
I have homework from this today.
Thank you. Just pay attention as we go over this. It's page M516. Check to see if you have that in your notebook. No, you don't. Yeah, I got no idea. I'm so sorry. I'll try to find it. It's got to be somewhere in my notebook or backpack or something. But I'm wicked confused. I don't know. So, shape. What are the things I'm looking for when it comes to the shape of each curve? It's not how high it is or how wide it is. I'm not looking for spread. I'm looking for modes, right? Either unimodal, or it could be, it's not here, but what else could it be besides unimodal? Bimodal.
Trimodal.
If it goes beyond bimodal, what we'll oftentimes say is just multimodal. Okay? Or I think that you had the one of uniform as well. Those will not show up on assessments. Those are just the different things that it could be. What else can we talk about with shape? Symmetrical, right? We're talking about being, the curves could be roughly symmetrical. What else? Or it could be skewed right or left. And don't forget, what defines whether it's skewed right or left? The tail is what defines the skewness, okay? So the tail is what defines the skewness. Those are the only things you should talk about here. Now, I will say, this is a special type of curve that is both unimodal, both of these, symmetrical. You could even call it bell-shaped. So what's the special name of this type of curve? These are normal distributions or normal curves. That's what we should have talked about. Both distributions are normal curves. Please note the shape that we're talking about there. Those are the things, when I ask about the shape of a curve like that or distribution, then we're talking about whether the modes, right, unimodal, bimodal, all that stuff, symmetry or skewness. But if you see that bell-shaped curve, you need to recognize it as normal. Yes, Alasia. Quickly. All right. Overall, we're pretty good at identifying and comparing the mean. Please make sure you note that detail of compare the mean, okay? The other thing I will say is we need to add a little bit more context. That's the only thing that I saw throughout everybody's. I saw people talk about Hoover and Washington, but what is it really about Hoover and Washington? They're what? And not just test scores, go all the way, standardized test scores, right? And actually compare them. Hoover with a standardized test score of 85, right? Notice I'm identifying what the, actually not just a standardized test score of 85, what is that 85? It's the what? Mean, right? With a mean standardized test score of 85 has a higher mean than Washington with an 83. It doesn't always have to be worded exactly this way. You can't, there's no formula to writing it correctly, but what you need to do is you need to identify the mean and you need to directly compare them. Notice how I didn't just identify the means, I told you which one was higher, right? From a statistical perspective, you need that context in there, you need the values if you have them, and you need to directly compare them. That's what I'm looking for. You good with that? Or questions at this point? And so overall, I will say we're pretty good. These are just the notes that I have to get back to you based on what I saw. Okay. Things we need to include. Melboria, you awake over there? Sure? Okay. So compare the standard deviation. So a lot of people talk about how Washington had a higher standard deviation. Did any of y'all actually identify what the standard deviation was though? Or estimate it? Tori?
Oh, well, I said, the highest number is moving 8 away from the mean, so is that like?
So that is a reference to spread, and I'm not sure if we had talked about it quite yet. Looking now, does anybody have an estimate for what the standard deviation might be? For Hoover? 2? How'd you get there? See, I might have even said a little less than 2, but yeah, I think 2 would have been okay. Notice, what am I referring to right there? What's that point?
Point of confliction.
The point of what?
Confliction.
Inflection.
Oh, my bad.
You're not inflicting it upon people, right? Okay, so point of inflection. So that's a good estimate, right? Just glancing at it, standard deviation of maybe 2, whereas Washington might have a standard deviation of
4.
3 or 4, right? 83 to 87. That's 4, yeah. Regardless, though, what we should have definitely noted is who has the greater standard deviation?
Washington.
Washington, and how do we know that?
Because of the fact that it goes up higher.
Okay, but what about the curve? What were you saying, Madison?
Oh, the curve is lower.
The curve is shorter and wider, right? When y'all talk about the height and the width, that's not shape, that is spread, right? So just noting that Washington had a shorter and wider curve would recognize that Washington has a higher amount of spread or a larger amount of spread than Hoover does. And so notice again that we want to directly compare, you would want context in there, okay? So those are things to consider, things to add in or make notes of so that you know how to do this a little bit better next time. Because these concepts will show up on your understanding check and on your test. Doesn't look like most of us need to write anything down. We feel confident. So I'm continuing. Okay, so where we got to yesterday, remember we're trying to use the empirical rule much like the problem we just did to estimate probability of an event. And so all we really talked about and got into yesterday was just looking at standard deviations. We didn't really look at real world context with it. That's what we're getting to today. So, right, we looked at our 68% within 1 standard deviation, 95% within 2, 99.7 within 3. And now we did activity 2.2 yesterday. This is still activity 2.2. Okay, so this is where we're starting to get into real world context. Did we start 2A? Am I remembering that correctly?
Yeah.
And I had y'all start working within your small groups as well before the end of class. Okay, so as a quick recap, all right, percent of adult males have a height between 62 and 74 inches. What we want to notice, that's between 2 standard deviations below and 1 standard deviation above. And when we work that out, what percentage do we get?
81.5.
81.5%. Okay? And so we use that empirical rule there. By the way, we were supposed to identify, is this a sample or a population? How do we know? The sigma and the mu. Remember, those are symbols of parameters of the population values, right? So population here. And there's my evidence. Now, I will point this out. On an understanding check or on a test, is that you giving me evidence that you understand why it's population? Yeah. That's not going to get you to really a 4 or a 4 plus. You would need more information for it, but that might be enough for a 3 plus, which is a pretty darn good score. You've shown me good evidence of your understanding. What else would you want to add in, though, to earn those higher scores to really show me that you understand why this is a population? Actually, I already mentioned it just a second ago. What tells you that this is a population? The symbols, but those symbols are what? Mu and sigma, but they're what? Parameters, right? Parameters, those symbols are parameters which always go for population. That tells me everything. That tells me, man, this person really understands why these are population values. Those are parameters, okay? And so those are the kinds of details I'm looking for. Quick show of hands, who did not get through B yesterday? Well, you weren't here yesterday. All right, so let's go ahead and quickly talk about B. Is B population or population or sample? Population again. So population. Once again, we're looking this time for females between taller than 68.5 inches. There it is. And so which direction am I shading? To the right. And what percentage is that? 16%. I do want to ask, what's the easiest way to get that 16%? Well, 2.35 plus 0.15. But again, that's going back to memorizing here and here. You can do that, but I would say even easier is this. And this might be something to note. What's to the right of my mean? 50%, right? And then that 1 standard deviation is pretty easy. What's the percentage between -1 and 1 standard deviation? 68 between -1 and 1. So what's right here? So if I take 50 and I take away 34, notice how I'm minimizing or doing my best to minimize how much I have to memorize. It's easy when you can just go straight back to your notes and identify these things, right? It's harder, though, when you're sitting on a test and you don't have those notes in front of you, right? Minimize the amount that you have to memorize. 68, 95, 99.7. Okay, so I know that to the right of my mean is 50%. I know I don't have that 34%, half of the 68, so I'm left with 16%. Does that make sense? What are your questions up to this point? Okay. Quick show of hands if we haven't finished C yet. All right, small groups, work on C for just a couple minutes. We'll come back together. Oh, true.
Let's just start this. Let's just start here.
Oh, yeah. I didn't need something with 68.
Just
Because I'm sitting at 34.
Is it that bad?
So really quickly, just to help show you this so you can come back to it later. Well, one, it has these notes right here. Between one below and one above, you have 68% of the data. Between two below and two above, you are looking at 95% of the data, and three below and three above. And so we're doing this idea of like, okay, well, if I only have half of that 68, well, then that's easy to figure out. So we're finding differences and adding them, things like that. Sorry, I forgot you weren't here. I had to come over first, but it's through there. I will also point out, if you miss a day, like yesterday, I had the video for this class even before third block. So if you miss a day, I'm gonna try to get those up as soon as possible. Search my name, that is the first thing that pops up. You find the Algebra 2 playlist within the channel. Sorry to cut you off, Peyton. You were doing a good job. I just wanted to point out that the information's there. It's also in the previous activity, 2.1. You good? Okay. Oh, thank you. Thank you. Okay. So what type of data do we have? Sample. Why do we know? X bar and S are called, well, it is, but remember, sigma is a standard deviation too. But what is it called when it's not a parameter? It's a, oh, we haven't looked at that one as much. It's what? That's where statistics come from, because you usually have statistics to estimate parameters, right? So it's a statistic when it's for a sample, okay? So we're looking at a sample, right? Sample, X bar and S are statistics. And this one was probably a little bit easier. Between 63 and 70, it's half of that 68, right? All right, so 34% there. Questions, comments, concerns? Feeling better? Need a little bit more practice? Maybe just a little bit? Yep, okay. And that's okay. And that's good. 2.3, this is going to be something quick that we kind of just tossed through. Okay? 2.3, I want you to notice, this is more notes about the similarities between all normal distributions and differences between normal distributions, and then characteristics of the standard normal. I want you to notice something, because this is going to matter in a little bit. Do you see how we have the 42, 49, 56, 63, 70, 77, 84? Right? And you see how it has X bar below it? So these numbers above, are those for a standard normal or for just a normal distribution? That's just normal. Because what is the mean for a standard normal? 0. So can you convert that 63 to 0? Maybe. I mean, they correspond, don't they? That 70 is one S or one standard deviation above. Could we just treat that as a 1?
Yeah.
And then a 2? And then 3? And then -1? I want you to hear me very clearly on this. Every normal distribution can be converted to a standard normal distribution, which is what we're going to do for the rest of this lesson and the next lesson. Because there are infinitely many normal distributions out there. Because there's infinitely many different measures of center, there's infinitely many standard deviations, but we can convert them all to a standard normal distribution. That is how we figured out percentages and probabilities of events. Okay? So that's what this is all about right here. Similarities between all normal distributions, which includes the standard, right? It's bell-shaped and symmetrical. We have the 68, 95, and 99.7. That's always going to be true. But the differences between all normal distributions is that the means can be different. The standard deviations can be different, right? So there's infinitely many normal distributions. But if I can convert that to a standard normal, then my life becomes way easier, right? Oh yeah, and this is something I should note. What we do, the reason why the mean is 0 is because we don't draw it in, but it's understood to be symmetrical about the y-axis, right? Notice this detail concave downward between 1 and -1, right? That's the point of inflection. That's how we know where one standard deviation is. So, anybody know what this word asymptotic is?
No.
Okay?
Oh, no.
Is it like,
Can't get nothing.
So, when we say, I think it's actually asymptotic, because it's an asymptote. But asymptotic means is approaching the x-axis, but it's never actually going to intersect. So if you see this x-axis right here, I was very intentional. Does that curve actually get to the x-axis? No. Technically, it goes for forever. Have you ever seen me actually have my normal distribution intersect the x-axis?
Yes.
I'm very intentional not to. Okay, that is a characteristic that it's asymptotic to the x-axis from above, meaning it approaches, right, but never touches or intersects. I would make a note of this because this will show up later in algebra or in algebra 2, and it shows up in pre-calculus. Asymptotic, that means approaches a line or curve, but never intersects. So that's not something I'm testing you on, but that's something you want to be aware of because that word asymptotic shows up in quite a few different things. Comes up with exponential functions, logarithmic functions, which we will study. It comes up within rational functions that you'll look at in pre-calculus. It shows up in several different places. So it's important to know that term. Asymptotic means it approaches a line or curve, but it never intersects. Okay. The mean is equal to 0. That's why it's symmetric about the y-axis. Standard deviation is equal to 1. And what is the area underneath that curve? What does it say? 1 square unit, because it is a total of how much percent?
100%.
100%, right? So 1 square unit for 100%. So it corresponds to the sum of all the relative frequencies of a histogram. What are your questions before we continue? You good? Give me the eye light. I don't know, Mr. Kenny. I kind of want to ask something. No? All right. So, here's the 2 questions on the next page. I want you to notice, is this asking for a percentage? What is it asking for? The area. So consider that. You can use everything you've already done, but think about the fact that we want an area and not a percentage. Work within your small groups to answer numbers 1 and 2.
No, for real.
What is it?
So that's what I want to call this, because I'm just pointing out that Kai's asking questions, trying to talk, make sure we're talking with each other. Hudson, or not Hudson, Owen, sit up, be actively engaged in that discussion.
Wait. So what's your unit? No. We will be looking at
So one thing I would remind you is, you're not always going to have that in front of you. What can you do? By the way, all 4 of us are going to be talking. Right, say that again, Celia. Can you draw the curve to get started? Before you even start trying to answer the question, you know you're dealing with standard normal curve. Go ahead and draw it. Get started there.
It'll be 2. It say 2 deviations below, right? Which would be oh, and 1 above would be we're looking at all the right. And so it'll be
I will.
so it'll be 2. But we're not looking at
We're not
that.
supposed to intersect anyway.
Shut up, dude. We talking about this, right?
Yeah.
And I'm right about that, right?
You said 2?
Yeah, it's a distribution between 2 standard deviations.
Say it one more time. The whole thing is how much?
Which one?
The standard normal curve.
What? Yes.
How much total area?
1 square unit. Right.
I thought it
So-
was
Remember that one square unit corresponds to what percent?
99.7. But you said all of it.
Right. What, remember 99.7 is only between -3 and 3, but it continues beyond that. What's the total percent underneath? So that one square unit corresponds to 100%. So what do you need to figure out in order to find the area underneath that curve? Hold on a second, answer my question first.
This curve.
But listen to my question again. What do you need to find in order to find the area underneath the curve?
We got shade.
Gabby, do you know? But you're not listening to my point. That one square unit corresponds to what percentage? So that area of one square unit corresponds to 100%, right? So if you want to find the area between -2 below and 1 above, what should you find to help you get to the area? Can you get the percent and then figure out the area from the percent? If you want the area underneath the curve, find the percent first. All the stuff, don't act like it's crazy. All the stuff you're doing here and here is what this is asking about. Find what's underneath that curve.
What did you say, 81? Just 81?
Micro. Times 10 to the negative. No,
Because one square unit is
times 10 to the negative.
This says the
You're trying to remember the curve.
The whole curve is one.
Yeah, but you said you were coming to tutoring and I would have helped you yesterday and you didn't come. I need you to focus on
What is
this.
it talking about?
How much are you talking about?
Yeah, that's the whole thing. Okay, I'm just making sure.
Come on now.
Okay, so I think it's just a point.
We haven't even written or drawn anything. What's the first thing we should do for a problem like that?
One. Okay, yeah, we're first.
Oh, yeah.
Can you draw that standard distribution? So one thing I will say, Colin, what I would do is I would work on not curving quite so quickly, right? Get a little bit of tail in there, like that. And I noticed what's the first thing I do to help things. That x-axis. So draw your x-axis to help me figure out where that area is. But what are you gonna do? I would try to, it's not a terrible regard, but I would try to, because you're almost like drawing straight on. What do you need in order to figure out the area underneath the curve, or do you need to find? Let me go check on those groups. Look, what's the area, the total area underneath that curve?
Don't ask me.
Previous page.
She's so weird.
One, what's the percent underneath the
Jay was
curve?
so weak, so then Jay was cool. Hey, I just thought about something.
Not underneath the curve. Remember, if you have everything, what percentage are you gonna have?
Can we just move the decimal to the left?
Right, so what percentage
Oh,
would
they both
correspond to
equal one.
That's not
Like how percentage is 1, 1, 0.
the area is equivalent to what they say. Okay, so I'll try to find the area by finding what first? Can you find the percentage between, is it 2 below? I got one.
Within a specific interval.
2 below, and then to 1 above. You see how there's a shape here? There's an area underneath that curve.
But if it's not, then it's like a line.
And that's the thing, like, we have a, if you can find the percentage, you can convert that to area very quickly. For instance, let's say you have 68%, what area would that go with?
So, never mind.
No, just think about it as a percentage. 68%, how would you get the area at 68%?
Why you divide 68?
100% area under the 30 came in.
No, that's what I'm saying. You can actually change this for the calculator.
You can find the percentage. You can find the
It's not what mom said I do.
Is the specific, whatever.
Do you understand percentages to areas? How they convert percentages to areas? Hey, by the way, guys, you need to make sure that you've done 1 and 2. Those are the instructions. 1 and 2. I'm working. I'll be there. Then also have to check on other people on the other side. What would 7 be? So then the area underneath the curve is 0.15. Like area is just the stuff in the middle. We're trying to find this stuff in the middle. If you can find the model, you can convert the area.
He has to be here. I haven't seen you.
And these percentages there are using the
It just went. I was listening to this and also
This is like a curve. As soon as you see standing on the curve, you let area.
I mean, like,
It's like
yeah.
or normal curve.
Okay. So we got 81.5, right?
Okay, then write it down.
Yeah, okay, so it's 81.5. I use this on it's 81.5.
100% is equivalent to 1. How do we go from 100 to 100? How do you go from 100 to 1?
You need to start taking.
You asked me zero.
That's not water.
Oh, you moved the decimal back. So I'm assuming that you're gonna move the decimal back. Okay, cool. It'll be point. That's what.
Snaggy, like it had.
Boom, that's it. Bam. No, I told her actually.
I'm taking.
What
What do you think it's like? Do you all have 81.5?
That's the percentage, right?
Okay. But look, here's 100%. And we're acknowledging that that's equivalent to 1. How do we go from that percentage to 1? Oh, that'd be 10. Let me point this out. 100%. What operation is per?
How was the area under the curve standing on
Division. Cent. What's that the root word for? Cent. How many centimeters are in a meter? 100. How many years are in a century? 100. How many Roman soldiers were in a centurion? Any guesses? 100, right? So what are we doing? We're dividing by. Anything? All right, keep working. We'll come back in just a second.
I'm sorry, I was trying to write something for her.
Hold on. What does it ask for? Okay, but we haven't done much with areas. What have we been doing with this whole time? Yes. Yes. We've done percentages, right? Okay, so I want you to think about it. What's everything underneath the curve? In percentages. Well, as an area, it's 1. But as a percentage, how do you go, so those are equivalent ideas. You can go from 100% to 1.
And a percentage adds up to 1.
That's 47.5.
Something with fractions, maybe. Yeah, regardless, though, I want you to think about it. Can you find the percentage? Could that tie into the area somehow? Find the percentage. We'll talk about how they convert it to area in a second.
I think it's just because they both make a whole.
Yeah.
How's it going?
Are you still?
You don't know? Okay. That makes sense. Okay, so 2. Go ahead and write something down. Or at least talk about it. We'll write it together. Do we all agree, though, we're thinking 8.5? Do you all understand from each other?
This whole thing right
Like, see,
here.
at least they're spaced out. So you can come back.
They both make a whole.
Okay, thank you, thank you. So let's look at it. I know some of us were struggling a little bit, but here's the thing. We should keep in mind our standard normal curve, right? And some of us were freaking out because like, Mr. Kinney, we're looking at area, it's no longer percentages. But if we're talking about standard normal curve or just normal curves, what should we always think about?
The center of the.
Yes, center.
Empirical rule.
Okay. If I'm looking at a normal curve, my first thought, even beyond the 100%, is 68, 95, 99.7. That's my empirical rule, right? So even if you're stressing about the area, do something you know. Start with something you know, right? Think about those percentages. I'm looking between 1 or 2 standard deviations below, I believe, and 1 standard deviation above. It's not a perfect sketch, but it's pretty darn close. And what's that percentage? You might have had this on the
68. 81.5.
might have had this on the bell ringer.
Hold on. Where that come from? No, you hush. Oh, we talking. Oh, cool, yeah.
So remember, what I would think about was between 2 below and 2 above, 95%. We only have half of that, so we're looking at 47.5%. And what's between 0 and 1 above? 34%. For a total of 81.5%. Anybody struggling with that percent, or are we okay with that now? Okay? So then, I want to point this out. 100%, and if you haven't seen me use this symbol, get used to it. That's the symbol for equivalent to, meaning they appear different, but they are somehow the same. They are connected to each other. 100% is equivalent to 1. Because 1 is the whole, right? It's representing everything. And what percent represents the whole? What percent represents the whole? 100%.
So you're going with the decimal back twice.
So you go, well, it's not just going with the decimal back twice. Yes, that's procedure to do, but can anyone explain to me why we move that decimal twice? Peyton?
Because 100% is like one whole something, and same as one.
Right, but like if I have, I don't know, 72%, that's going to be equivalent to 0.72.
True.
Why?
Because.
Oh, we're dividing by 100. I want to point out something to you. Break down the language of this. 72%, break down that word, per, which could end up meaning that you would multiply, or it could mean that you're going to, what other operation? Divide cent. How many pennies are in a dollar?
100.
100. How many centimeters are in a meter? 100. How many years are in a century? 100. So we're talking about dividing by 100, which gives me my 0.72. So when I have 81.5% and I take my 81.5 and I divide it by 100, I'm looking at an area of
0.815.
That's it.
That was easy.
Okay? So how is the area under the curve of a standard normal distribution related to the percent of the data within a specific interval? How are they related?
They're both equal, like a whole.
Well, it's not, so they're talking about like, you're talking about the total area, right? We're just talking about an area under the curve within a specific interval, right? So how do we go from the percent to the area? You divide by 100, that's it. So I do also want to point this out. Hey, what if you wanted to go from an area to a percent? You'd have to multiply by 100.
True.
That's what we want to notice and we want to pay attention to. To convert from percent to area, you just divide by 100. To convert from area to percent, multiply by 100.
You good?
Yep. Had a little phlegm stuck, haven't been getting enough sleep, busy, you know, teaching,
The usual.
preparing for life, but more to the teaching side of things.
Yeah, like life is tiring.
To teach?
I'm going
I mean, I have a baby on the way, so a lot.
What does that Can you read that last sentence?
To convert from area to percent multiplied by 100. Notice it's literally just going the opposite direction or the inverse direction. So you're doing the inverse operation.
You gotta reach up there.
Dude,
No, I
You gotta start that.
I haven't decided how dad jokey I'm going to go with it. I'm more like the super dry humor type of guy.
You can't do that for
So.
like a 4-year-old. You gotta.
If I train him up right, I can. You got to start with the sarcasm early. All right.
Your child will be ready to move up by the age they hit 5.
Okay, we're going to quickly talk through these so we can get to the next lesson. This is 2.4 data distributions. I do want us to, I'm going to give you, let's say, 60 seconds per, take 60 seconds, talk within your small group just to decide with number 1, can you use the empirical rule? So talk within your small groups for 60 seconds, can you use the empirical rule? Well, you
Which only applies to normal.
That's a good question. Think about it.
It's not a normal distribution.
Typically still, right?
You got chill.
Yeah, I'm sorry. That was you're being a little too accurate.
That's the 95, 99.7 that you've been using. The empirical rule is that for a normal distribution, 68% of your data is between one standard deviation below and one standard deviation above them. 95% of data is between 2 below and 2 above. That's the
Okay.
Thank you. All right. So, can anyone give me an argument maybe that we should use? Does anyone think we should use?
I think we
So-
should.
Okay, so Lita, what's your reasoning for that?
Oh, dang. Because
The empirical.
She don't know.
I don't know.
She do know.
She said, well, because what if it's wrong? Then I'm being embarrassed. I ain't gonna never raise my hand again.
Okay, then say
I mean, it sounds like a personal problem. It's this weird thing where like I'm okay with people being wrong and I encourage you to be
Alright,
wrong.
So I said no because the empirical rule only applies to normally distributed data sets, and it's not,
Oh.
it's like categorical.
It's weird. It's
Yeah.
it like JC quickly put her hand down and Owen and Hudson put their hand down as if like, man, I have nothing else to add on to that because that killed it.
Right.
Stop being scared.
No ideas are.
All right. So I will point this out. Is this categorical data though?
no.
It's yours.
Dude, 3,000 a way.
But that's, hey, you don't.
Oh, no, those are
That's not
Yes,
Is that years? That's the number of home runs hit in an MLB season. Right, but notice, look down here, there are no years there. The number of home runs, hey guys, number of home runs hit in an MLB season tells me it's numerical, but also, hey, what type of graph is this?
A bar, not a bar.
Histogram. Histograms always go with numerical data.
And they always taste too. Dang, we're slow.
Okay? Histograms always go with numerical data. The bar charts where the bars are separated is categorical. If those bars are connected, you're looking at numerical data. This is histogram. No, not a normal distribution. What would we call this that prevents it from being normal?
What you call
Not
it?
abnormal.
Screwed right.
Not screwed right.
Yeah,
Skewed right.
You said screwed. No, but what we call it for real?
Skew right.
Skewed right. It's just not screwed right. There's no R in there.
Okay.
It's a K, also not a C, okay? So it is skewed right instead. That's what prevents it, okay? That took longer than I expected. move on to 2. Looking at 2, what do you think?